Alright, so we're going to kick things off early today. I was late the first 3 days, but now we're starting 10 minutes early. So here's my printer build so far. This is the Ratrig V-Minion. Hello, Russian character dude. Not sure how to pronounce that. But we're just going to get started with the build here. I did a couple of things off stream, but really it was pretty minimal. I just changed my wiring so that I'm being powered off of this Dell laptop power supply now. This massive power brick. So that just gets rid of the hassle of trying to figure out where to attach a power supply here. It's just going to be sitting on the floor there. And that's in, let's see how much power we've got here. This is a 19.5 volt, 16.9 amp power supply. So it's pretty powerful. Hey Race Bear, welcome. So it's a pretty powerful little power supply here. It's a little bit lower than 24 volts, but there's a little secret that not a whole lot of people know. And that's that you can run a 3D printer on pretty much any voltage between 12 and 24 volts. And it'll be just fine. So 19.5 volts, we're splitting the difference. And yeah. So my big challenge today is going to be installing this hot end. Getting this so-called EVA hot end going. I'm just printing off the last parts right now. They're just about to finish up. And here's some other printed parts. I attached this little top cap. It's nothing really too crazy. And I got this little end cap that I'm going to plug in right here. Alright, so those two parts are plugged in now, and we've got that other print finishing up. I got a whole tray of parts that should be everything I need to do this hot end here. So when we get to that, that'll be pretty fun. But in the meantime, I can finalize some of this wiring. So I'm just going to start plugging some things in. I got some wiring for the whole hot end. This should be pretty much all of the cables I need to power everything on the hot end. I just need to run this stepper motor cable through this this harness here. So I'll just stuff that in there. Here goes. 10.5 is a laptop power supply. Yep, that is a Dell laptop power supply. Oh jeez. Hopefully this thing's alright. It's a Dell laptop power supply, so I think it was around $100. They aren't cheap, which is unfortunate, because if they were cheap, you could just use them for all sorts of 3D printers. But originally, I was using that laptop power supply on my fanless build. I built a 3D printer that didn't have a single fan on it, and that was a pretty fun little project. One of my greatest videos to date. But let's just fish this through here. And then I've got a couple little wires to do my fans. So I'll get those fished up. Whee! Hello, for Scene Gaming. So my goal here is really just to get this all finished up. So I've got a lot of ground to cover here. I'll be fine if the wiring isn't all done, but if I can get the hot end installed on here, then everything should be pretty easy from there. I'll just have to deal with the firmware and stuff. Alright, this is never as easy as you think it's going to be. I should have used my other cable ties, but this is what I had already cut to length, and I'm like, might as well use it. So this type where you have to fish everything through the hole. Alright, so now I just got to make sure these fan cables make it all the way through. So I'll just pull this. Pull this all the way down. Come on, fan cables. I soldered the 220 ohm resistor and plugged the Noctua into HF2, but it needs help getting going and then spins very slowly. Alright, so you're probably talking about one of my modder boards, so let me think about that. So are you running on a Sonic pad? Just out of curiosity. Oh man. These things are awful. I really don't like this kind of cable wrap. I'm just going to pull this off and get some other type, and I'll show you what the good stuff is. But yeah, if you're running a... where's the Guinness for the vid? Oh, sorry, I don't have any Guinness today. I don't think they'll allow me to have any Guinness on camera after what I did to the last one. Okay, yeah, so the Sonic pad has this weird issue where they limit the fan throttle in their setup for the code. If you look at my Sonic pad on the Ender 5S1 video, or maybe it's one of those videos, I go over some code that I put on there. Basically, I replace... I can actually show you on stream here. So if we look here, this is the best way to capture a screen. If I go to my configuration, if we go to printer.cfg, on the Ender 5S1 and possibly the Ender 3, if we go down to this part, no, not that one. I commented it out, I think, so here we go. This part, this, whoa. Yeah, so let me zoom in on that. So this is the code that it originally comes with. So if you go into this, just like I showed you, that's your printer.cfg file. So this is your web interface here. Go to configuration, printer.cfg, and then scroll down to this line. This is where it's setting up your heater fan. And it looks like, I don't know what the default settings were, but for some reason it wouldn't turn on. But when I just replaced all of this code with these 3 lines, which is just like a very basic definition of the fan without anything, without all these extra lines here, it fired right up. So give that a try and see if your fan will get working. You'll just replace all of this with these lines here. And I outlined that in one of my videos. So I think it was the Sonic Pad installation on my Ender 5S1. I go over that. So yeah, that should answer your question there. I'm gonna go get some better cable wraps. I just gotta hop downstairs 1 minute and get them. Yeah. Oh, I'm streaming right now, baby. So here's my different type of cable wrap. This one I can just open it up from the side, so it's a lot more convenient to work with. So here goes. All right. So today's stream will probably be about 3 hours. I'm going to see if I can just finish all of this up in record time. So let's see how it goes. All right, so all the cables that we're going to need here are our fan cables and our hot end cables. So here's the fan. These four will be used to power my fans. Here's our extruder. And then here's my hot end and thermistor cables. So we just get all of these lined up just like that, and you can just stuff them all into this. No problem. It's a lot easier than the other type. And Prusa uses some that are similar to this, and I have pretty much that exact same cable. I have that exact same cable wrap. But I think this actually looks pretty good with my clear white stuff going on. So I think we've got a pretty slick looking build here. I might need it to be a little bit longer, but this is looking pretty good as is. Alright, so then as the tool head's moving back and forth, it'll have this kind of whitish tether thing. And yeah, it does look like I'll need to make it a longer cut next time. But for now, this will work, and this will help me get everything installed. So I think I'm going to cut these bed cables short as well, just because there's so much extra cable length here. Or better yet, I'll just tuck them away. Let's just get them out of here. I think the best thing I can do is just kind of jam it in the corner. This is not great, but this is all going to be shoved into a box and then closed eventually. Alright. As you can see, my cable management skills are non-existent. Okay, so if I tie those up, I'll put another zip tie on. Zip ties to the rescue. And then I'll kind of loop this up into a big bundle and tuck it away in here. Alright, so that's looking pretty good now. This will just kind of go around here somewhere. Yeah, that's fine. This is going to be a mess. Alright, so then I also figured out how to wire up my Raspberry Pi. So I've just got this cable. This is actually the Y-axis end stop. That was originally on my Ender 3 or VoxLab Aquila. This is the Y-axis end stop, and I found that it's got the exact right connectors to be able to power this Raspberry Pi. So you just plug it into the fan plus and minus, and then plug that into the power pins for this Raspberry Pi. And that's how they tell you to do it in the Ratrig instructions. It says to just go from that fan port over into the positive and negative pins over there. So that's looking pretty good. So I think I'm going to get everything going except for the fans. So we'll do this without any fans to start with. And then after that, we'll work in some... we'll just basically get it working without the fans and then enable that later. Alright, the next thing I've got to get onto this tool head will be this Pinda probe. So I'll add that to my wiring bundle here. Alright, looks good. Now I just need to start putting this X-axis assembly together. I'm going to go check on my prints. They should be done. And before I do that, let's check on the chat. See, oh yeah, nice. A bunch of people are in here now. So, welcome everyone. Don't mean to derail you. Appreciate the help. Okay, yeah, no problem, Jake. Yeah, that should get you going. It was kind of frustrating when I first plugged in the Sonic pad and the fan didn't work. Mr. Ed, how much is this kit? So the kit that I have here is about $200. They sent it to me for free. Ratrig sent it over. However, it doesn't include the bed heater, which is pretty much a mandatory thing you need to buy. And it didn't include this bed leveling probe. So I ended up buying those separately. And so I've got about... I had to buy about $100 of parts from Ratrig, and also the Raspberry Pi and the main board are self-sourced, as well as the extruder and the hot end. So depending on how fancy you want to get with all the other components on here, this can cost you anywhere between $300 to build up to like $600 or $700. So it's kind of you get a lot of flexibility, but overall it's just like a really solid frame to build a 3D printer off of. It's really nice and compact yet sturdy, so I like it. Alright, so I'm going to go grab those prints from my Bamboo Lab P1P. I have all of the parts that I need for this hot end. They should be just about done now, so we'll pull them off the tray on camera. Let's go grab it. Alright, so it took me a while to get all these parts ready and really understand how this whole hot end setup works on this printer. So let me just pull all of these off. But basically, they call the hot end the EVA hot end. And it's something that was developed by Ratrig for their own printers. and it's kind of an open source project. So people can contribute to it and they upgrade it. There's different versions of it, so it's just kind of a neat thing. But I wasn't sure if, I don't think I printed out all the parts that I needed the first time around. So I just went to the EVA documentation website and downloaded the full set of parts that I'll need. And now, since I did that, I shouldn't get confused when I'm trying to put this together. So that'll make things a little bit easier. Ooh. All right. So this part printed with a brim for some reason. So I've just got to shave off some of this plastic. Alright, so here's all the pieces. Now we just got to put it together. So the setup that I have, and if you go to the EVA website, they've got a bunch of different files for all sorts of different configurations. But for my setup, I'm using the Bondtech Lite, LGX Lite here, and the other piece I'm using is the Fetus Rapido. I just gotta find it. Here it is. So here's the Fetus Rapido. So basically I just gotta find a way to put these two pieces together and attach it to this tool head, and that's what the EVA does. And it's looking like it's a little bit different in its design than the original one. Ooh, this looks quite different actually. I don't know if this is gonna fit on my printer, because the belts look like they come around the front. That's completely different. Oh no. Well, let's just see if I can put something together with the parts that I have. So, I'm guessing on their other Ratrig, the belts get attached to the front of this front plate. So then that's like up here and sliding back and forth. But on the V-Minion, it's got a little bit different setup. It's not a Core XY, so you don't have this type of belt termination. Instead, you have it all running around back. So let's see if we can figure out a way to put this together now. This looks like it goes up here. Oh yeah, yeah. I think this will work. Alright, so it looks like this goes up here. So we'll bolt that in place. I'll just kind of follow the documentation on I gotta pull up the V-Minion documentation. Okay, so if we look over here, yeah, that's interesting. So this front piece has those little serrations, like there's belts that get installed there. But really, it gets the belt gets installed here. And this other piece that I printed doesn't look like it has anything to have that belt installed this way. It looks like they switched over to a different type of belt fastening. So on this original print, it looks like we've got the belt kind of being inserted into the printed part, and it just kind of grips on there. But on this one, it looks like we've got a double-ended belt tensioning system. So yeah, there's some definite differences going on here, and that's kind of the problem for me, at least. So it looks like I might need to print a second one of these out. But even that I don't think would work. So yeah, that's this is just the type of thing that you come across with a kit like this, with parts that are changing in a bunch of different configurations. I'll try and find the piece that gets installed into this one. Looks like this is the part that gets inserted in here. So this will be our tensioning mechanism. So, yep, just like that. The belt will come around like this and get inserted like that. And then when you fasten this, it kind of pulls that block in and gets everything tensioned. So I keep printing parts out hoping that it'll make this thing come together, but it doesn't seem to be wanting to come together quite so easily. Okay, well, at least I'll get my Fetus attached to this block. These parts don't look like they're made to go together, but they must work together somehow. I can't figure it out. Alright, so let's see if anyone's pointing out something obvious in the chat. KP3S on steroids, yep, I agree. I wasn't as big of a fan of the KP3S. You're prototyping, so cable management module off, yep. Don't need to worry about cable management. I have a fear of falling stuff when I watch Nathan's videos. Yep. Good thing the MacBooks are so cheap. It's just kind of dangling off the edge of the table there, so it should be fine. So let's see. Maybe like this. I'll just get these screwed in at the top here. I mean, with how tricky this all is, it almost seems like it'd be easier to just get a pre-assembled hot end and throw it on there. But that's not really an option for me right now. And these are supposed to go together like this. But it just doesn't look like it's going to happen. Well, maybe that's upside down. No. Alright, there's clearly some kind of disconnect here. am not smart enough to put this thing together. Wait, here's this front plate is involved somehow. So we get this like that. Okay. Alright, I think we're getting somewhere. This goes in here. Then... Okay. I think I'm getting this. So I need to press the nuts into this plate. We'll see if it's the same as the last one that I printed. I already pressed nuts into this one. So yeah, it's the same part. We'll just go ahead and reuse this. And this gets pressed in here. Alright. And then this gets attached here. Very good. Alright, so okay. We've got some hope of getting this put together correctly. Now, as you can see, I'm assembling this in a different location than last time. So I kind of lost track of a bunch of tools and bolts. So that's just going to make this even more challenging. So I think this goes into this plate. Maybe a slightly shorter version of this bolt. Okay, let's see. I've been meaning to drop in and say hi. Hello, John. Also, do you think that KSP Pro S1 would be better for a sleep-deprived dad and modding needs instead of V-Minion? I wasn't a huge fan of the KPS Pro. The King Rune KPS, it just didn't have good print quality, so I buy printers to print things with, and if it can't print things good, then it's not much good for me. So really, you have to have good print quality out of the box if you're gonna impress me. And the King Rune didn't exactly deliver in that regard. So yeah, I mean, this is a good kit. It's just this part is really confusing me. Maybe it would have been easier if I bought the full kit, or it could have helped if like I just had some instructions on what parts to print. But I think we're getting there. Alright, next piece. I'll assemble this bit. Looks like these are the right screws. Oh wait, nope. I need shorter ones. But yeah, this is a struggle. I'm of the same opinion. Good print quality is a must. Yep, I think so. I found the Ender 2 Pro was a really good printer in terms of print quality. So I wouldn't shy away from that printer if I was looking for something. And it looks like these are M2 or M2.5 screws for threading this on, which just makes things lovely. It's great when they do that. So I gotta find my my box of bolts with my M2.5 screws. First I'm going to check to see if these M2s fit in there, because I'm not exactly sure what size threads they used on the top of this. Yeah, that doesn't work. So I'm pretty sure they used M2.5 screws on this Fadus Rapido, which is just great. These parts don't come in the kit. They should have been provided with the Fadus Rapido, but I lose track of a lot of things, so I'm not sure if I have those screws anymore, which means I'm going to have to get creative. I think if I get those, I have a kit that has some, let's see, this one. This kit here has got some M2.5s, so I'll give that a shot. So what if they're flathead cap screws? They'll work fine. So just verifying. Yep, those thread in. So put this back in place and bolt it down. There we go. All right, lovely, exciting 3D printer assembly action going on here. And since I'm using tiny little screws here, I need to find tiny little Allen wrenches to drive them. Alright, let's see if these are the right size. Will they thread in to the hot end? Seems like it's doing something. Cool. Alright, so that's going to work. I think I'm actually going to swap these out for a longer size thread, because that's going to be a little bit stronger. So I'm going to be using M2.5 by 10 flathead hex socket screws. Yeah, that's working a lot better. So I'll swap all those out to M2.5 by 10s. Yeah, so these are printed in PETG. I don't know if you can get ABS in this nice clear color. But in any case, I don't plan on running this with an enclosure. I've got a bunch of other printers that I'd rather enclose rather than this one, because the whole point of this is to be small and light, so an enclosure wouldn't be great for its overall use case. I've got a P1P and an Ender 5S1 that I'm planning on enclosing as soon as I get around to having the time to doing that. Alright, let's get those screws. So we've come a long way in this build. It's been about 10 hours of assembly so far. If I was a little bit smarter and possibly a little bit less distracted by the stream, I could see it going together in maybe 6 to 8 hours. But it's still a substantial time investment to get this thing going. And the tricky thing about M2 and M2.5 screws is that you'll tighten them down thinking that you're not over tightening them, but it really doesn't take much to drive these. So it's pretty easy to strip them out or break things. But there we go, that's all done, and this feels really sturdy. That's a nice little assembly there. So then I can attach this to this piece. Just like this, like so. Yep, that'll do the trick. And it looks like we're gonna need maybe a 16 millimeter long M3 nut for this one, M3 bolt. Maybe 25. Let's see what we got here. Alright, let's zoom back out a little bit. It's getting a little claustrophobic looking there. So I gotta clean out these holes. Basically when this prints, it's got some sacrificial material that it lays down on top of those holes just to help with print quality. But you gotta pop that out. It's kind of like support material. Basically it lays down a little bridge for when it changes diameters for that countersink. Alright, so here we go. Yep, that looks like the right size. So I think these are the M3 by 25s. So I'll pop those in. So once we get this all put together, do you think I should do a live stream of the firmware flashing, or should I just wait until the firmware's all done and then show it off? Let's see, somebody's talking about, do you think Creality can kill the bamboo? Yeah. Well, Creality's got a huge market share, and they've got tons of money to throw at this problem. So I think they're going to spend a lot of money trying to beat Bamboo at the speed printing game. And I'm getting a K3 next week, so if you're curious to see how that machine performs, definitely make sure to tune back in and subscribe and all the things. But it should be a really interesting review. I've got the P1P, so I'll be able to compare it against that machine. Alright, so this is looking pretty good now. Cool. So then this gets attached up top here. Might as well get this pretty much attached to the printer. We'll give some context to this build. Showing it attached to the printer will just, it'll be nice to see. Okay, so these screws are too long. The ones that I grabbed, I think these are M3 by 12s. They're a little bit too long, so I think I need to use M3 by 10s in this hole. Fortunately, I have a whole box full of M3 by 10s. M3 by 10 is objectively the best bolt size. M3 by 10. the best one. Usually I buy my bolts in kits where there's a bunch of different sizes in a box, but M3x10 is worth buying a whole box of. All you need is M3x10s. So let's get that fastened. There we go. Okay. So the reason why they have slots, I was a little confused here because we're using slotted holes instead of just round holes for these fasteners up top. But I think the reason for the slots is that it makes it compatible with more different types of carriage blocks. So you've got this smaller sized carriage block that it fits onto, but I think even with a slightly larger carriage block, we'd still be able to bolt this type of tool head on here, which is nice. It kind of feels like Ratrig is an enthusiast version of a Prusa machine. Like, there's nothing wrong with Prusa in terms of their print quality and speed, but if you really want to go fast, something like a Ratrig, I think, does a little bit better job. And it's got pretty much the same philosophy behind its construction, using PETG parts and a minimal amount of metal hardware to get this thing put together. So how much do you think the new Creality Bamboo Killer is going to be? So it's the K1, and I saw that Creality was doing some market research. If you went to the K1 launch website, they had a little questionnaire that was like, how much do you think the K1 should cost? And I posted a link to that and told everyone to say it should cost $400. I can almost guarantee it's going to be more expensive than that, but you can kind of hope that it might be a cheapo machine. Alright, so next step is to attach this back plate on here. I'm going completely rogue. I'm not following instructions anymore because I just got confused by the instructions and kind of lost, so we're just going with it now. Going by feel. So, I think here is where I'm going to use some of these longer bolts. So this is kind of the longest bolt that I've got left in this kit. Seems a bit short for this application. Yeah, that's a little short. It needs to be a little bit longer, so I'll see if I've got something in the hardware kit for that. Alright, we've got some longer bolts. So these ones, I'll go straight through here. That's probably what we want. And we might have to twist it to get it in there, so let's just drive it in. So in one of the first episodes of this whole saga, someone was saying I needed more clamps. We'll see if my clamp will work here. It's just barely too short. But I can use it to apply some leverage. Maybe I could get some kind of hammer. Let's see if this works. There we go. And it appears that I'm following the wrong order of operations because this other part is in the way. So let's see if we can just get past it. There we go. That's working. There we go. Oh man, probably wasn't a good idea. It'll be fine. Alright, so let's keep driving that in. So I still need more clamps. Alright, we're almost to the end here, and the threads should be popping out the backside. Oh no. They're not popping out the backside. How could they do this to me? Man, it's not even close. Okay, so probably grabbed the wrong size screw there. I'm just gonna take this piece off so we have better access. Oh man. Okay. Leave that one on. I'll take this one off. Now, if you were hoping for a straightforward build guide video, that's not what this is. This is just me trying to get the thing put together. Alright, so that didn't go all the way through. So I must have been using the wrong sized bolt. I've got a full set of M3 bolts, so I don't have to be stuck with these tiny little ones. Ugh. Come on. This is like a very non-ergonomic work desk situation. Having to hunch over this thing while I build it. I'll take a seat. Now, this is supposed to sit inside of here, and it should stick out just barely. But the head of the bolt doesn't fit inside of this hole, unless you really kind of force it. Alright. We need some clamping action here. Alright, that's just barely sticking out the back now. I think it needs to be pushed a little bit further so that it fully sticks out the back. But you basically need an arbor press to push this in, which I don't have. So I'm gonna have to use Mr. Clampy here. Oof. Now we can hammer this in. So I just need the right kind of tool to push on it. So we'll get this. And we'll just go like this. Oh man, this is not going to be easy. Oh. Okay, I'm reconsidering my approach here. So if I get a clamp, I just need something to get in there and push on it. That's not right. Alright, so we'll get an M2.5 bolt that fits into the head of that M3 bolt perfectly, and we'll clamp it. But there's an issue here, and that's that on the back side, the bolt is poking out just barely. So when I clamp on that surface, it's just pinching everything together. I need to have a little pressure release shape back there. Alright, so there's our M2.5. And I've got a washer on right here. We'll clamp on this. Alright, there we go. We got some movement. Alright, so now we've got just enough sticking out on the back side there that I can get some thread engagement. So now we'll just twist this with a nut attached to the back. And that should pull itself through. Or if I just twist it like this, maybe it'll move. Yep, it's going through. I'll zoom in here. Get you right into the action. Alright. So now that's sticking through the back side just enough that we can start threading it onto that nut. There we go. And hopefully this other hole, there's another screw that we got to put through there. Hopefully that one's a little bit easier to drive. This one seems like it's going in a little bit easier. Hopefully I'm not going to have to take this all apart and start clamping again. Alright, we're really close here, but it's just needing to go a little bit further. Alright, and that's threaded in. And we'll torque those down a little bit. Wow, we're really getting to clamp down on this. Just pulling these pieces together. I guess because it's a sandwich of like 4 different parts. Very good. And we'll do the other side. Very good. Okay, and then there's this bottom plate. This comes along right here, like this. And then this just gets tightened down onto this, just to close up this box section. Pretty nice. It looks like this bottom piece uses the same sized fastener. So I'll find 2 more of those and get that tightened up. So one of the issues here is it looks like, I'm always complaining about how they should use common fastener sizes and there's too many different sized fasteners. But it looks like they compromised the design here a little bit to make sure that all 4 of these use the same size fasteners, when they could have just made everything a little bit longer. Or left a little bit more tolerance on some of these other parts. But it's going together. It's just taking a little bit more time. I think this goes just like so. Okay, it's these inner holes. That's what I wanted. All right. All right, let me see what's going on in the chat. On the Creality website, it's $504 for the S1 Pro with the Sonic pad. Yeah, I'm guessing it's going to be $599 or $699, just to put it right in line with the P1P. Like, this is pretty clearly a printer that's designed to compete with the P1P. And I've got some contacts at Creality, and they've told me that there's another printer coming out after the K1 that's going to be even faster. So we got a little teasers going on. But I should be getting all of those in for review. And say what you want about Creality, but I really appreciate how they send stuff over for me to check out. Because the way this YouTube channel works, and pretty much every other YouTube channel, it really relies on getting some source of just being able to test out the latest and greatest printers. So it's really nice of them to send stuff over. And if you know the history of my channel, historically I have not been very kind to the Creality designs, nor have I been kind to Prusa or pretty much any other printer. I just review them as if I had just wasted as much money as the MSRP is, and I'm just furious about it. So that's my review format. Alright, so looks like we put this on right over here. See, the problem that I was having earlier is that I was trying to follow the instructions, but as soon as I freed myself from the instructions, all of this is coming together much easier and much faster. So if I could give any advice to someone putting this kit together, is to just throw the instruction manual away, delete it from your web browser, and just go for it. It'll probably be fine. Alright, so that's attached there. I guess now I need to feed this belt through. Let's get you a better angle here. Now we're working on the belt train. So I'm feeding the belt in the top, and it's going to spit it out the bottom. Now this step is pretty similar to what I had to do for the y-axis. They don't give you a whole lot of guidance on how to do this. You're supposed to just jam the belt in there, and it's supposed to just pop itself out the bottom, which it will eventually, so just have patience. I think, oh, there we go, there we go. Is it going? There we go. Alright, we got it. But to make that a little bit easier, they could have had a little pass-through or some kind of viewing window where you could kind of help it along. But we got it, and it's something that you're not going to have to mess with very often, so just all these little things that take a little bit longer end up kind of frustrating me just because they add up. Alright, and then we're going over here. I'm going to wrap this around the stepper motor, and unfortunately I forgot to put the stepper pulley on that stepper motor before I put this together, and it looks like it's going to be a real pain to get that apart. Because I can't unscrew these stepper motors from this angle. I have to pull this block off and then mess with the stepper motors and then put it back on. Ugh, that's not going to be fun. Well, I don't know if I did the instructions out of sequence or what. I probably just didn't follow the instructions there, despite my best efforts. So we're going to have to fix that. And I might even just swap this out with this part, which is printed more solidly. We got extra layer lines here, so let's take this off and get that stepper pulley installed. Let's see, Anycubic coming out with a speed printer too? I'm not sure. I don't have any contacts at Anycubic. I know JJ Shankles does, so I'll hit him up on the next podcast. So perfect first layer, check it out. Yeah, I'll be filming another episode of the podcast on Friday, and we're going to have a lot to talk about. So I'll see if he's got any info on Anycubic or Elegoo, which I think he's worked with both of them before. Yeah, so on Creality website, it's $504 for the S1 Pro with Sonic Pad. I think it's really looking like the K1 is going to be $699 or $799 at most. So it's going to be pretty much the same price as the P1P. And keep in mind, the P1P, they don't include free shipping in that price. So you have to pay like $20 shipping, which is a little bit, but it does bring it over the $700 mark. Okay, so yeah, let's take this apart now. I have to undo these screws on the top and bottom to get access to it. So here goes. And I need to get my special Allen wrench. Will this work? Yeah, we got an Allen wrench for it. Okay, so to get access to this stepper motor and to change out the stepper motor if you ever wanted to change it out, this is what you'll have to do. Unscrew these 3 bolts that are holding this stepper motor block in place. And you're probably just going to want to unscrew them all the way. Actually, you'll want to extract them, probably, just to get this to come off. They seem to want to hold themselves in there. So, Nipex to the rescue. Or Nipex, as the Germans say. Alright, we got 1. 2. 3. Okay, so those are all pulled out, and now I'm just going to remove this stepper motor. Now we can pop this stepper motor off and put the correct belt on there. Alright, does this feel like a tank so far? Yes, it does. It feels very sturdy, especially for being this cantilever construction. It's kind of absurd how rigid it is, given that it's just got 1 arm over here. Alright, now let's poke these out and install them into this other housing that's printed out with a lot more layers and infill. So some of these parts I printed out with lower density than I would have liked, and some of them I printed them out with extra density, and I think the only one that I might want to reprint at the end of this process is this one over here. This is a pretty important part because it's holding onto this X-axis belt and it's under constant tension. So having extra thick layers on this one would be pretty nice. So I might end up reprinting this piece, but that's pretty easy to get access to, and it's all out at the end here. But yeah, let's get rid of this one. This was the old one, and we're using this one now. So, all right. So here's our stepper motors. These are our Creality stepper motors that we're using. I'm going to drop these 4 bolts straight down the holes. And to be specific, these stepper motors that I'm using are the ones that are used for Creality extruders. So I'm not sure if they're even wired remotely correctly for what I'm planning to do with these. I know there's like a speed versus torque trade-off with a lot of motor design problems. So I might end up in a situation where these are just not fast enough. But it'll be a good demonstration of how the wrong stepper motors can ruin things. So now I just need to find that pulley belt, that belt pulley. All right, here we go. And I think I'll put it on backwards because that's how I did the last one, and that worked out pretty well. All right, so there we have it. No, we don't say that. What do you, is it Nipex, how I normally say it, or is it Nipex, like knife? I heard someone call it Nipex once, and now I'm all worried that I'm saying it wrong. Okay, so that doesn't really line up super well, so I'll just loosen that up and push that belt in a little bit further. I don't know if you could see that. Yeah. So here the pulley doesn't line up super centrally in there. It's kind of off to that side. So I'm going to loosen these up and push it in closer towards the motor. Alright, that's pretty central now, so we'll go with that. I'll just torque that down for now, and we can adjust it later if we need to. And you want to put a decent amount of torque on these, but don't overdo it. They're M3s, so they can't handle a huge amount of torque, but it's good to make sure that they're not going to come loose. Because if your stepper motors come loose, you're going to have to take this thing apart quite a bit to get to it, as we just demonstrated. Alright, that's all good now. So I'm still confused on this whole hot end situation. I printed it out several times and I finally got something that works by combining the old parts that I printed and the new parts that I printed. It might be worth taking a minute to just fully understand how that all goes together. But as you saw, I just winged it and it worked out fine. So all right, and oh no. Oh no, I did this all wrong. Okay, so this hole isn't important at all, and that's what I was using to line things up. Turns out these holes are the important ones. So, all right. I'm just going through the instructions real quick. Well, I'll loosen that up. I think I can access it through these holes. Alright, and then we'll flip that back around. Now I think the way I do this is I want to line up everything just like this. There we go. And then I use this hole up at the top to tighten them down. Alright, that'll do it. And looks like I can just barely get the short end of the Allen wrench on there. I'm tightening these down in the wrong sequence. You always want to make sure to tighten down the flat part of the shaft first, because if you don't, then it's not going to be, there's not going to be that positive locking feature that helps kind of center everything. Alright, just lining this up now. Alright, so we got the flat side tightened, and then we got this extra screw to tighten down. Alright, and that should be ready to reassemble, so let's just throw this back on here. Hopefully those T-slot nuts didn't move around at all, otherwise this is going to be even more painful than it needs to be. But they should stay put. Alright, let's anybody having a good chat in here? I've had no problems with my Creality printers. Everybody is entitled to their opinion. Yeah, I've dealt with a lot of Creality printers, and they have a pretty poor track record with quality. The ones I've been getting lately have been pretty good. I mean, they've all been somewhat working out of the box. But back in the heyday when they were mass producing Ender 3 V2s as fast as they could sell them, there was a lot of them that just weren't very good. So I totally get why people still view Crealities as having a black mark for quality. Plus my Ender 5S1, I got a really early version of it. I think I got like a pre-release one. Mine had a bunch of issues and they've since revised it. So there's the version 2 of the Ender 5S1. That's just slightly different. They just changed the position of the BL Touch probe, and they're using injection molded parts instead of 3D printed parts in a couple locations. And they said they reinforced the structure. I don't know what exactly that means. So, you know, I think they are taking quality a little bit more seriously. What I think they need to do, more than anything, is improve user experience. Because it's all about user experience nowadays. Alright, so now I'm just feeding this belt through, and it's coming right through. That's nice. Okay, so our x-axis is coming along pretty nicely here. I mean, at the start of the stream we didn't have any of this, but now we've got the full thing assembled almost. We got the belt on there, so it's looking pretty good. When you cut this belt to length, you definitely want to be reading the instructions though, because if you cut it too short, you're going to be in a rough spot. So let's figure out what length to cut this belt to. Oh wow, there's another part I think I forgot. Oh. Okay. I think I'm missing a piece here, but I'm okay with that. Like, this is looking pretty good as is. I think there's one more part that they want you to install. Let's see if I can find it. This little guy, so I think it's supposed to go in here. Wow, that's really tightly integrated. I'm not sure how essential it is. It might be for a different type of hot end, so I'm just going to leave it alone. I don't think I need this. But they talk about that in the instructions here, so that's probably for a different hot end. All right. Then we've got the fan guide. I don't think I need any fan guide on here. Yeah, we're just not going to worry about fans until later, because that's just going to add more wires and complexity, and I want to make sure all this other stuff gets wired up correctly first. So we're on install the X-axis belt, which is step 32 of the EVA assembly. This thing is a ton of steps to put together. And where's that part that I had earlier? All right, so this little piece gets, holds onto the belt. You can see it's got some teeth in here, and it just kind of clips onto the belt. Just like this. Oh, those teeth are kind of messy. So, I printed this in the wrong orientation. Yeah. Definitely should have been printed like this, and I think I printed it like this. So those teeth kind of were laid down in midair. That wasn't a good choice. The nice thing though is this looks like it weighs about 1 gram, and it should print out in about 5 seconds. So I'm going to go ahead and fire up, let's see, my Ender 5S1. Since that's already good to go, I'm going to switch this over to main screen mode. Alright, here we go. Let's add a part. Here you can see my upcoming videos. I've got my SVO6 and I got a 40-watt laser. I've got all the stuff filmed for. Ratrig, V-Minion, CAD, printed parts, machine, STL. And then let's just find that piece. It's a little baby part, little itty bitty one. Tension slider, 6mm belt. I think that's it. So we'll open that up. And then lay it flat like this. And my Ender 6S1 is set up to almost over extrude a little bit. So I'm not sure how this will turn out. But I definitely want to turn those perimeters, the external perimeter. Yeah, that's slow enough. This should turn out all right. Let's see how long it takes. 11 minutes. So this is the glory of 3D printing. We get to print stuff out in 11 minutes. I think I'm going to slow down those external perimeters just a little bit more, just to make sure they come out nice and clean. And let's see. if there's any flow tuning I can do. I'm not seeing it. We'll just print it out and see what happens. So export G-code, tension slider, 6mm belt. And then we'll drag and drop that into our printer files. And here we go, print time. Let's see if I can see my printer. There we go, it's getting started. Our bed's installed. Should be all good. So while this is going on, I'm gonna get back to the build. I don't know if you want to watch this. Maybe we can just keep our eye on it, and I'll go over the chat. See what everyone's talking about here. So I'd rather buy a Sovol than a Creality. They spend a little more on rods or linear rails. That's true. I mean, but you also have the Ender 6. I think it's made with V-slot wheels on the y-axis and linear rail for the x-axis. And I think, I mean, I don't have any insider information on this, but I'll suspect that the K1 series is going to have linear rails or linear rods, because they're directly trying to compete with the Ender 5, no, sorry, the Bamboo Lab P1P. So we'll see what comes out there. And I'm going to be doing my Sovol SV06 review soon. I'll spoil it just a little bit by saying that the belts that it has are a little bit crunchy. I mean the linear bearings. They're a little crunchy. It's not the highest quality stuff. And yeah, as Guy the Jedi says, Sovol uses Creality parts. So there's a ton of parts in common between Sovol and Creality. For some reason, Creality sells parts to Sovol, or maybe they're the same company. I have no idea what the internal relationship is. But yeah. John Stern, Creality also has too many printers. Yep, you got that right. So if I open up my Creality slicer here, let's look at how many printers Creality has. I hope this is coming through all right on stream. Oh no, I didn't switch it over. Holy cow. There we go. Yeah, here's the Ender 5S1. It's getting ready to go. It's just heating up right now. Let's see. Yeah, it's almost up to temperature. That bed's got to heat up. So if we go over to Creality Slicer, I think it was John's point. He was saying that Creality has too many printers. Let's see how many printers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 50, 60, 70. So about 78 printers that are supported in their slicer currently. So that's interesting. Also, there's a Creality chocolate here. I'm not sure what that's about. CR3040 Max. I don't know what any of these printers are. CT400, CT380, CRX, CRM4, CRM5. Ender 7, let's see if we've got, what's that printer that's coming out, the K1? I don't know if the K1's in here yet. Yeah, I think these are ABC order. So yeah, there's a lot of printers there. It's like 78. Way too many. I mean, Bamboo Lab has 2 printers right now. So they're able to really kill it when it comes to tuning those and getting them to be pretty much perfect. And if you look at these print profiles that the printers come with, Ender 3S1 comes with a 50 millimeter a second print speed. Ender 5S1 comes with 80. So these really aren't pushing it. And let's just look at the accelerations too. Expert. I'm an expert. Show me the accelerations. Maybe I'll just hit all. So acceleration. Yeah, they're set to 500 millimeters per second squared acceleration, which is nothing. If you look at the Ender 3S1, for some reason the Ender 3S1 stock profile has a higher travel acceleration than the Ender 5S1, which is completely wrong. We look at the CRM4, that's that giant printer. So let's take a look at the accelerations. Yeah, that thing's a big slow thing. 300 millimeters per second squared. That's why it really makes sense to put a large nozzle on that machine so that you're able to get more done. And let's see the print speeds on this thing. 50. So this is set up to go as fast as the Ender 3S1. Good to know. Alright, goodbye Creality Slicer. And here we've got our first layer going down. You can't see it because I'm using invisible PETG. Especially when it's up to temperature like this, it's really hard to see anything. So, but I'm assuming that print is going along just fine. Let's get back to the build. I think I've got a couple other things to work on here, so alright, I guess I can't do this X belt just yet, but I can start working on this extruder mount. So we need to attach this up here, just like that. Maybe like this. No, just like that. Nice. So this top piece is specific to the extruder that I'm using. I'm going to go through some more of the comments though, just because we've got a good chat going here. Nice is it a stack of... Oof. I didn't even bother tuning my V-Minion's bed leveling, I just rely on mesh bed leveling. Yep. Well, I have this 1, 2, 3 block, so I can check my squareness of the whole frame. It seemed pretty good. I was doing a little bit of testing earlier. It's definitely sub half a degree, or I think it's sub half a degree, so that's pretty good. Sounds good to me. I'm going to go through these instructions here and count 8 teeth. So basically I'm going to pull this tight, see where it touches here, and then count 8 more teeth. So 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going to cut that. I think I'm getting an Amazon delivery, so I'm gonna, let's see, I'm just gonna mark this. Alright, I'll come back and cut that. 1 second. I think I got some stuff, some goodies coming. Alright, So anyways, let's cut the rest of the way through that belt. I think I'm gonna use some clippers to make sure I get a good cut there. Alright, so that'll just get pulled in there using that little block that we're printing out right now. Okie dokie. Alright, I want to get caught up on the chat though. It seems like you guys are going a little crazy in there. So yeah, Creality's got too many printers. They don't use V wheels. V wheels are a non-starter for me. I don't really see the problem with V-Groove wheels. They work just fine. Maybe you can't hit like over 10K accelerations with them or 20K, but it's not too big of an issue for the printing that I do. Does this printer you're printing use springs for the bed? Yeah, so this just has some nylon washers and stainless steel spacers. I covered that in an earlier part of the build, but we'll just take a peek down there so you can see what's going on. Also, yeah, I guess I can show you some other stuff I was working on here. But there's your stainless steel spacers. They just bolted straight onto this. So it's mounted on there quite rigidly. And so one thing that I worked on off camera was I cut a magnetic sticker sheet out. I had some larger pieces, and unfortunately this is right in between the size of my Ender 2 Pro and my Kingroon KP3S. So I think the Kingroon KP3S is actually 200 by 200, so that's a nice size. This printer is 180 by 180, so it's a pretty significant size difference, but I think 180 by 180 is actually the perfect size in terms of having just a small printer to crank parts out on, because the bigger you make this bed, the heavier it gets. So yeah, especially like a big thick cast plate like this. If you make a big thick cast plate large, then it's going to be real heavy. So especially if you're doing a bed slinger, you want to have this be as light as possible. I just had to shave this off. Get a nice clean edge there. Also, when I was handling these sticker sheets, I noticed they're quite heavy. I think they have iron filings in them, or iron powder, so it's pretty heavy. If there's a way to do it without using these sticker sheets, kind of like how Prusa does it with their, all of their printers really, they use permanent magnets, like neodymium magnets, which I think are lighter, and you can get them in higher temperature variants, so you can have a hotter heated bed. These will demagnetize, I think, at a lower temperature. I'm not 100% sure on that, but that's just my my gut feeling on it. So, yeah, that part's printing out on the Ender 5S1. Just checking on the feed there. Looks like it's 75% done. So, here's your little preview. It's looking good. Hopefully that part works. And what else can we do? Yeah, I need to get some square nuts for this this Bondtech LGX light extruder. So I gotta find some of those. I just need I think I need 3 square nuts, but I only get 1 in the kit for this printer. So I'm wondering if I can actually get away with using regular nuts. like non-square nuts. It's worth a try. I'm willing to see if it'll work for science, so that you don't have to. Alright, so I'm going to try this out without square nuts, and if I really need those square nuts, I'll be able to scrounge some up. So the way this Bondtech LGX works is there's a couple spots where you can embed nuts into it, but for some reason they didn't include them in this build. So they just left them out for some reason. I guess it's to save cost, maybe to save weight. And they figure you need to take this apart and insert those nuts so that you can add hard points where you need them. I've taken one of these apart before, these Bondtech LGX extruders. They're really awesome. So here you can see our two teeth there, and here's a little lever. So this lever applies tension and releases the tension. So you can just throw this lever, and then you can pull your filament out, put your new filament in, and then re-engage it, and it clamps back down. So there's no spring-loaded like spring that's constantly squeezing the filament. So it means you can do one-handed filament changes. So you just pull this out, pull the filament, put it back in, throw that over. It's really convenient, and I think it's quite a brilliant little design here. And they're using laser cut or water jet cut steel part here, which should be nice and durable. But enough about that. Let's see if we can use regular nuts here instead of square nuts. So I'm just gonna, those are too thin for these to fit. This looks like, just talking about 3D printing technology in general. So this is a 3D printed extruder. This whole thing's been 3D printed. And it appears to be this special process that I learned about when I was touring Xometry. It's either selective laser sintered, or it's this other process that I think HP developed, and basically they spray black pigment onto a bed of powder, and that makes it absorb more radiation, and then they apply a really bright light to it, and that heats it up, just the layer where the pigment is, and then they lay some more powder material down, and then put a new layer of ink on there, and then hit it with the light again. So the nice thing is, I'm not exactly sure which process is being used for this, but if this is that process that I'm thinking of, it's a pretty cool process in that it doesn't require any lasers. So it's like doing it all with traditional inkjet technology. And it can do a whole layer at a time for the heating, and you can get inkjets to print pretty fast if you like overclock them and tune them. But anyways, I've got to put these washers, no wait, sorry, these nuts into these little slots here. And it doesn't look like it's going to go in very easily. So what do you think we should do here? Should I order some nuts and wait a day for them to get here? Or should I just wing it and see if I can make something happen? Wow, and if you look at this, if you take the actual stepper motor off, this is just a tiny little block of plastic. It's really lightweight. Pretty impressive design by Bondtech. Alright, so if there's a way I can press these nuts in here, I think that's going to be the fastest and easiest route. So let's just take this, set it up, just prop them up into place, then using my my 1, 2, 3 block. Well, actually I won't use the 1, 2, 3 block. It seems nice and hammer-like, but this is a precision tool. We should use something else. maybe this thing will work. Let's see if it works. Okay, that didn't work. Oh yeah, I can set these up in arbor press mode and squeeze these nuts in. All right. I don't know about you, but I think this is gonna work. All right, just like that. Okay, here's what I'm gonna do. I'm gonna put this off on the edge. I'll get my precision needle nose pliers and we'll get this right in position. Give it a squeeze. All right. Of course, this is nylon. It's pretty springy. All right, we squeezed it into place. It's looking pretty good. Wow, and just look at all the detail in this 3D printed part. This is a really good example of a part that's really taken advantage of 3D printed technologies. So, put that back together. I need to put one more nut in there. There we go. I got the other one squeezed in there. And they got to go a little bit further, so I'm going to add another little something to, so I can push a little further. So maybe I'll squeeze this zip tie up against it. Okay. Well, now that it's held in position, I think I can hammer it a little bit. So I just need to get a screwdriver or something. That didn't appear to work very well. So I definitely need to find a way to squeeze this to get it into place. Are there any rational people in the chat that have objections to the way I'm doing this? Because if you do, you can get out. There we go. Just a little bit further. Alright, that's good. And then I've got one to install, I think right here. This one. So let's get to it. Now Bondtech are probably pretty disappointed in seeing how I'm brute forcing this. But they make a fine product that can handle a little abuse. It's kind of like my Knipex pliers. So I just want them to know that me doing this to their products is a vote of confidence. But yeah, it's totally my fault that I'm having to do it this way. I'm sure that they included those square nuts in there. Actually, I'm not sure, but it sounds like something they would do. Alright, I'm going to get a little more aggressive with these things. I'm going to use my other Knipex pliers. These have a little bit more range and are a little more grippy. So that make this a little bit easier to do. There we go. Nice and easy. So then I just get this Allen wrench, set it kind of on the side here, and then pinch on that Allen wrench. Ah! Almost there. There we go. Okay, so now all of these are nice and threaded. We got some nuts in there, so I can just attach them onto this plate now. The nice thing about this Bondtech extruder is it's really easy to take apart and put back together, hopefully. Oh yeah, that just goes on there. This goes like, probably like this. Yep, okay. Alright, and just like that, we're back together. Put this front plate, I don't know if this is the front plate or a back plate. Just slap that on there. That goes on this side. Alright, nice and easy. Look, it spins freely. And now we just put the stepper motor back on. And there we go. Everything's up and oh, sorry, you might have missed that. But I got it put back together. Everything's all working good now. So here we go. All right. Alright, in just in a minute I'll go down and get that last part for assembling the X-axis. I gotta find my Allen wrenches because I dropped them all over the place. There we go. And there we go. Okay, all ready to put this back together. And now we're just gonna attach this using some handy dandy screws. First one will be in through the side here. Alright, I'm gonna catch up with the chat, see if anyone's horrified as to what's going on here. Unga Bunga. Yep, I solved that problem with pure Unga Bunga. Y'all ever go to the zoo and watch the monkeys? Monkey strong. Yeah. How long until I realize? What did I not realize? What did I do? Unga Bunga, Unga Bunga. Manuel says square nuts. Yeah, I know. I just don't have them. This came with one square nut. I'll show you. I can't even find the one square nut. So, just so you know, if you have one of these LDO, Bondtech, Sprite, whatever, what do you call it? It's a LGX Mini. You can get away with using non-square nuts. They've overbuilt it enough that it's just such a great piece of machinery, and you can totally do it. I'm hoping those are the correct size nuts. They're M3s. Do you have any plans on building the Rook? I would love to build a Rook. I gotta finish this one first though. I could either get a kit from the company that's doing them is, forget the name. I talked to them at East Coast Rep Festival. They're nice guys. I'll think of it. It's Fabrico. So I talked to them about maybe having them sponsor an episode. They haven't got back to me yet. But yeah, definitely would like to work with them because they've got a lot of cool printer kits. And they're nice enough to take on Rollhan's project and sell the Rook as a kit. So The nice thing about the Rook is I think most of the pieces can be sourced from an old CNC machine, like those 3018 CNCs. They're just like the really small desktop CNC machines. It's got all the linear rails and stuff, so you should be able to get it. All right, John, thanks for joining. Have fun dropping your kid off. M3 square nuts. Yeah, 2 minutes. This beautiful piece demonstrating the precision, and then start smashing it with wrenches. All right, Fabrico. Yeah, Ratrig. Yeah, I'd like to work with Fabrico, so I'll hit him up. Now that I'm actually putting some of these kit printers together, I'm proving that I'm. I don't know if I'm smart enough, but I'm definitely tenacious enough to get these things assembled. So I'll be right back. I'm going to grab that little piece that I printed off. I'll switch the camera over so you can watch me grab it off of the Ender 5S1. All right, we're going to go get it. All right, and here's the little piece. So here's the little part. Not the best print quality. You can see it's got a little booger on there. And that brim, I need to shave that off. So let's get that taken care of. If you don't have one of these, you definitely got to get one. This is a deburring tool. They're used by machinists to shave off corners on metal parts, so they're more than enough for the job for shaving plastic parts. And they're just fun to use. It's kind of like a potato peeler for mechanical parts. Alright, and we deposited a little booger there, so it looks awful. And that's something that happens with pretty much any printer when you're printing PETG. Even on the Prusas and the Bamboo Lab, when you're printing PETG, every once in a while it just blobs off a little crusty thing. It might happen a little more often on my Ender printers just because it doesn't have a nozzle wiper or anything. But we'll see if this works. Here's the moment of truth. Will it work? Come on. You just kind of have to fit it in here. All right. Come on. There we go. It's going. It's a very tight fit, but that means it'll be strong. So that's kind of the theme of this printer. Everything's a tight fit and kind of difficult to put together, but that means it should be pretty dang strong. So now that we've got this inserted here, we've got our little belt clamp. I can just insert that block into the side of this other part. And when I tighten this down, it will tighten the belt down. And before I install that, I'm actually going to chamfer all the corners just to make sure it fits nice and easily in there. Because you want it to slide somewhat freely so that its tensioning action can work. But you don't want it to be too loose because then it's going to be sliding around in there and not being super precise. So I'm just going to chamfer that. Chamfers all around. Alright, and here we go. Plug that in. And then, I'm not sure exactly how this works. I think I'm supposed to put some kind of fastener in there. So let's consult the instructions. Oh, a square nut. Dang it. So we're going to need a square nut after all. This kit comes with one square nut. The Bondtech, I believe this comes with square nuts, but I lost the packaging a long time ago. But this kit comes with a single square nut that I need to use right now, so I gotta find it. Alright, since I'm struggling to find this, I might as well struggle to find it on camera. So, no. These screws, T-nuts. Cap nuts, regular nuts, and lock nuts, drop-in nuts. Oh, here it is. There's our one square nut. So it would have been nice of them to include some of these square nuts, but I think in their default kit they actually specify to use one of these Bondtech thingies, so they just assume that if you're using this extruder you'll have those square nuts handy. But I did not. Let me pull this piece out. So apparently this square nut just gets dropped into the bottom of this hole here. So down the hatch it goes. I'm not sure how well this is going to fit, but we can get it to fit. We've made hex nuts fit where square nuts are supposed to go, so we can get square nuts to fit where they're supposed to go if needed. Yeah, so the thing about PETG overhangs is they're not that great. And we've got kind of an ugly surface here. So when you're designing something, it's like a build your own adventure kind of thing. And you got to decide what the priorities are in your design. And it seems like at every fork in the road, Ratrig decided, we make this strong. We're going to make this really strong. So there's a lot of decisions that they made to make things as strong as possible. But often that'll come at the expense of ease of use and ease of assembly. But that's their choice. I'm not going to judge it. I think what I'm going to do here, I'll probably deviate from the instructions just a little bit. And I might just put one of these in here. That just fits in there too good not to do. So this is just one of these heat set inserts. I can just drop that into the hole. And that looks pretty good. I might melt it in a little bit. Why don't we do that? That way it'll be nice and strong. So, to get things melted, we gotta add heat. So we got our torch, and here's a little thing that we're gonna torch. So here goes. Okay, so this is what I'm gonna do. We're gonna get all torchy. I'm gonna heat this up, and we're gonna stuff this in there. Alright, this brass is changing colors. That means it's probably pretty hot. I'll dip it in here. Just kind of shove it in a little bit. Whew, that gets hot. Alright, I'm just going to thread this. Oof, I don't know if I'm ruining this, but here goes. I'm just going to thread this through. Oh, that's a bad idea. That's the story of this build, though. Alright, so I might have messed up a little bit here. We'll see if we can clear this out. I think I need to get a drill and kind of drill this out now. Or I can melt a way through. So I think what I'm going to do here is heat up one of these Allen wrenches and then just kind of poke this to kind of clear that plastic glob out that I just produced. Or I can try just threading this in on this side and poking that blob out. I think this is working. Oop. What's the saying? Solve fire with fire? Yeah, this is working just fine. So, yeah, basically when I pushed this in, it created a little dam of plastic that blocked up that hole. And that's kind of blocking everything. So when I feed a screw in from the other side, it's going to get blocked. But I'm just forcing this screw through that blockage, and now it's just poking it out the other side here. So there it is. Here's our little blob. Now we can unscrew this and get this all put together. Sounds like a little mouse. Squeaking away. All right. So that should be nice and strong. That's going to be, I would wager that's even stronger than the square nut that they called out. So that goes in here. And then we get a bolt that comes in from this other side that just kind of cinches this all together and tensions the belt. So let's get that installed. Oh yeah, anyways, I was showing you, this block gets installed here, and then we tension it up. So now I gotta find the correct length screw for that. That's probably a good question to ask the manual. And according to the manual, we are using the M3x40 cap head screw. I've got plenty of those in a little toolbox, so I'm just going to use one. It's always good to get M3 screws of every type and length because they're handy. Alright, here's our M3x40. Goes in just like this, and we'll just get that threaded in. Yeah, my PETG overhangs were awful there. We have technology. Just 3D print a square with a hole in the middle and heat press insert into that hole. Clearly makes the most sense of all options. Yep. Oh hey, SK39. Hello from Germany, Cologne. Nice to meet you. Thanks for joining the stream. I'll have you know, on my YouTube analytics, the US is the #1 country for viewers, and Germany is #2. So, for some reason you Germans like what I'm doing here. Not sure what it is. Maybe you could help me explain. Or help explain it to me. This has become a Nipex commercial, yep. I mean, if they start paying me, I'll be happy. But it's a free Nipex commercial. Bolt tightening ASMR. That PETG grinding noise. This is getting kind of hard to turn. Hopefully this all works out. This thing's going to be super solid when it's done. I mean, just listen to that. This is basically a solid piece of plastic by the time it's done being tensioned. Is it actually moving? I think it is. Let's get a close-up on that bolt being tightened. All right, let's see this. Now you got a macro view. Is this working? It's kind of worrying me now. I think it's working. Now my Ender 5S1 does tend to over extrude because I set it up that way. I always like over extruded parts more than under extruded. But for dimensional accuracy, having a little bit of under extrusion is a good thing. Now it's a lot easier to turn for some reason. I think we just had to break through some initial resistance there. What do you think? Does that look pretty good? All right, so that is the X belt. I think one of the last things I need to do is put this extruder motor on there, so let's just get that done. Now that I've forced those square nuts, or those hex nuts into the square nut hole. Let's see. To access all of the fasteners on this, I'm going to need to remove this hot end. But I'll just get this one nut put into the side here while we have access. Or one bolt. Oh no. Are these the wrong size? This doesn't seem like it's a clearance hole for an M3. Well, we're just going to have to make it a clearance hole. But yeah, the tightness of all the assembled components of this thing is just, it's a constant. Like, everything on here is tight. Yep. Well, that's not long enough, and I dropped my Allen wrench. Good thing I've got about 20 Allen wrenches for the M3 size. Okay, so I need a little bit longer than this one. This is a super short one, so. Alright, so I'm going to keep the stream going for one more hour. We'll see how far we can get in this build. I'm really hoping I can get all of this plugged in and at least ready to start putting firmware on it. That would be really nice. Okay, so this is a 6mm bolt. I need to use a, let's see, I need to use an 8 or a 10mm bolt. I think a 10 is going to be too long, so pretty sure I need an 8mm. I'll see if there's any in the kit. I'm not seeing. Oh, here we go. We got some 8mm right here. So I'm just going to measure them before I get started because it's always good to have that extra bit of certainty when you're putting something together. So if things aren't going together right, you know, it's one less variable you got to worry about. So yep, this is 8mm. And just to show this tip off, I know anyone who's watched the last couple of streams already knows about this, but if you need to measure the length of a bolt, the easiest way to do it is just like this. Put the bolt on the end of the calipers like that and close it. And use your step measurement surface, just like this. And we've got 8mm. So here's our 8mm bolt. And we're attaching this fancy little extruder. Oh no, is this not? This is gonna work. Okay. All right, and then I have to take off the hot end that I've got on there. This Revo, no, not Revo. Gotta take off this Fadus hot end. Then I'm gonna assume I just need some more M8 8mm long fasteners for this. M3x8. Let's attach them. There's one there, and I'll get the last one out. Ta-da! Oh, geez, I just over-tightened that, and it's spinning freely. I don't know what happened there. That's very worrying. Uh-oh. Oh no. Please forgive me, Bondtech. What have I done? What the heck? Oh man. I think I need a slightly longer bolt for this one, so I'm going to switch over to my M3x10s and see if that solves the issue. All right. There we go. That's better. I think it was just kind of threading into the housing, the plastic housing, and it wasn't actually engaging the nut up there. So I'll replace these with the M10s. And one cool thing you could do if you were building a kit like this, and this is something that I'm going to do on my own kits if I ever make one, is use different types of bolts finishes for different purposes. So if you have a M8, if you have an M3 by 8, if you do a black oxide finish and make all your M3 by 10s silver, then there's a quick visual, easy distinction between the parts. And that's just going to make assembly go that much faster. Because really, for most of the stuff that we do with 3D printers, it's not in a corrosive environment or anything near it. Other than in the toxic comment section, that's the closest they get to a corrosive environment. So really, we don't need specific surface finishes for these things. Anything will do. Indoors, in regular temperature and humidity, it's really difficult to get materials to rust or corrode. Okay, so that's all assembled. Now let's put that hot end back on. There it is. And we're all good. Yay! We did it! Oh, one last thing I need to do here. I need to insert a tiny piece of something to guide the filament. So just a little Teflon tube. Let's get that installed so we don't have to worry about it anymore. So I'm definitely going to put a Noctua fan up here with this little fan cover, or maybe I'll print this out of some other material or color, just to have like a little accent on there, or just leave the Noctua fan in all its glory, just out front like that. I like that Noctua fan aesthetic. I'm going to grab some PTFE tube. I'll be right back, and then I'll check on the comments section. Make sure you guys aren't getting up to anything too bad. Oh wait, here's our PTFE tube. We got it. And it's the right color. I like how manufacturers of PTFE tubes have just started to make them blue, because Capricorn tubing came out and everybody wanted blue PTFE tubes. So now whenever anyone sees a blue PTFE tube, they're like, oh, nice. It's a high temperature Bowden tube. That's not necessarily the case. Pretty much anyone can just add some blue dye to their PTFE tubes, and you'd be fooled by that. So, good job, people. This is actually a pretty thin-walled Bowden tube, but yeah, I think I'd get a little bit better precision if I used some more precise stuff. So I'm going to get a little segment of Capricorn tubing. This stuff has a pretty large inside diameter. Probably pretty hard to see on the camera here, but can you see it? I'll get some other stuff just so that we can compare. So here's some other PTFE tubing that's much thicker walled. We'll get them right next to each other. And I'll cut a fresh edge on this one. Come on, autofocus. Do your thing. Okay, well, there you go. So we've got our thick-walled tube and our thin-walled tube. This one will be better for like a reverse Bowden application because it's going to be less likely to like bind up for whatever reason. But this one will be better for having more precise control over the extrusion. But I'd be a little bit concerned about having some kind of clog or jam in here because of how small the inside diameter is. That said, I'm willing to take a chance on this one. Let's just install it and see how it works, because potentially we're going to be getting better precision out of this part, so that's worth the risk. And I'm going to put a little chamfer on the inside edge here. Well, let's see. How much length do we need here? Okay, then let's put this end in like this. Alright, so that's only like less than an inch that I'll need there, so let's chop it. Alright, and once I get the length set correctly, then I'll start putting a chamfer on either end of it, just because that's easier to do afterwards. Noctua have low flow. Fabuca has some black and red. I have some coming today. Oh, nice. Tom Sandler has a high humidity in his basement and corrosion issues with screws and bolts. That's really interesting. Where did you get that cable sleeve from? I got this on Amazon. I can post a link to it after the stream is over. Or I probably won't do that if I'm being honest. But if you just look up cable wrap white on Amazon, you can find it. Oh, Tom, I think Tom's in Germany. I guess he's in Switzerland. I don't know. You want a tight ID on the hot end feed tube? Alright, I will go with the tighter one. Big gulp straw, or boba straw. Yeah, Bavaria. Ja. So, put a counterbore on the end of the tube? Yep, I'm planning on doing that. I have a counterboring specific tool, which is great for this, but I'm not feeling like digging that out of the pile of rubble in my office right now, so we're just going to have to deal with it the way that it is. Alright, so let's get this. Get that length set correctly. So looks like we gotta cut off about 3 millimeters. Alright, I'm going to chamfer both the ends. I just twist it with a razor blade, kind of sticking into it. Get some razor blade ASMR here. That good old razor blade scraping noise. Alright, so I'll put that in here. And that is just a tight fit, just like everything on this machine. Push that in, and now we'll put this in place. It goes this way. Seems like I might have cut it a little short here. Feels like I'm about 1 millimeter short. Is it worth the effort to recut this thing? Probably. Oh no, this is a lot longer than I thought it was. I wasn't pushing this all the way into the Fetus Rapido hot end. Well, dang. Okay, gotta have a new game plan here. So I'm gonna chamfer this end and push it all the way in to the Fetus. Alright, so I'm going to push this all the way in. It's a really tight fit. And I'm going to use my handy Knipex pliers because they've got so much teeth on them that they're going to help me push that into place. Alright, and then we'll figure out how much length we need past this point. So I'm just going to cut this so that it's even with this surface. I'll at least put a notch here. And PTFE is slippery, but Knipex pliers will grab right onto it. So I need to cut off this much, basically where that line is. That should be just the right amount. All right. All right, and then I'll chamfer that right up in the microphone for you. And actually, I should be more careful with this because those little bits of PTFE could easily clog the nozzle, so probably want to clean this out. It'd be nice to run some filament through there just to make sure it's clear, but this zip tie will do the job. Alright, make sure that's all cleared out, and then push it on to the Rapido and install into the Bond Tech. And that's just right. All right, so we'll get that fastened up. And see how that goes. So hex-shaped Bowden tube with hex-shaped filament will get optimal quantum flux. Yeah, hex-shaped Bowden tube with hex-shaped filament would be a great idea, because then it wouldn't rotate in the tube. Then for your multicolored filaments, or if they have some advanced directional properties, you won't have the filament spinning around. It's a great idea. Okay, and let's get this all assembled. This might be just a tad bit too long, but we'll just compress it a little bit and install it. And if we have issues with jamming, we'll take another look at it. But the nice thing about this hot end, as far as I can tell so far, is it's really easy to remove parts from it. So just taking it apart and servicing it will just be really easy. So that's probably one of the reasons why people like these machines so much, these Ratrigs. It's because you got this easy to service modular design. You can just reprint parts if you ever have issues with them. Just seems nice. Alright, so there's our x-axis. All done. I'm not even going to put a fan on here because you don't really need a fan. Yeah, cool. Now here's our wiring. Yeah, and I need to install the Pinda probe. So here's the little probe holder. I'm not sure where this gets attached. Looks like right here. Yeah, definitely goes right here. So, probe install. It looks like I'm supposed to put some nuts in there and I didn't, so that might be pretty annoying to get to, because it looks like one of these I can't get the nut past this little Rapido thing. So I'm going to find a way around that, definitely, because I do not want to be stopped at this point. Of course we got to use more fire, so let's melt our way into this little spot here. So what I'm going to do is I'll just heat up this screw. This one right here. We'll get it up to temperature. And before the heat transfers through this bolt and burns me, we'll melt some of this plastic out of the way. Alright, and just like that, I've cleared away some access so I can drop that nut in there. And then obligatory Nipex usage. We'll just use this thing right here. I brought a Super Pinda for my V-Minion. It's better to have thermal compensation, but I've never felt the need to put it on. Huh. Yeah, I don't know enough about what the Super Pinda offers. I wish Ratrig would just thread directly into the PETG sometimes. They really go overboard with making sure all threads are metal on this machine. I think they could simplify things quite a bit if they would just be okay with threading directly into plastic. I do it on my designs all the time and I've never really had an issue with it. If you're assembling and disassembling it 100 times, then you might start having issues, but stuff like this where you're probably going to put it on and take it off maybe once or twice, it's not that big of a deal. Plus, a better alternative would be heat set inserts if you really want to have that durable metallic thread in there. Let's get those. You know what, does this really need two nuts in there? Or can we just get away with having one? Alright, we're doing this again. More fire. Now if I wanted to show off, I'd get this red hot and have it glowing, and then plunge it into this part and have it be like bursting into flames. But I'm not trying to put a show on here. I'm just trying to get the job done efficiently. So if we can melt this out. Ah, no. I just dropped some stuff. Okay, here's our first non-Nipex tool. We're not going to talk about it though. I've got some little snub nose, needle nose pliers. They're from Weller, in case you're wondering. All right, let's get that. Let's get that in there. These Weller snub nose ones are pretty nice actually, so if you're looking for some tools of the non-German variety, you can get some of these. Okay, is this gonna finally fit? Oh, I think we're good. We're getting there. There we go, come on. I hate this. I straight up don't like this. Alright, well, that's as good as we're gonna get. Now I think I need maybe a 10 millimeter. And honestly, one screw is going to be fine for this application. We don't need 2 screws. But then again, this is moving at pretty high accelerations, so that's probably why they want to be extra careful and make sure everything's all good. Well, shoot, I'm not sure what to do here. This is just getting ridiculous. I'm going to try one last thing, which is going to be to put a larger bolt in there, which might be able to reach that nut and pull it into place. So here goes. Here's an M3 by 12. That might give me enough reach here, but I might have to even go up to an M3 by 14 here. Okay, looks like we're starting to reach it. We'll try this one more time. You must see the fire. Alright, so let's just kind of heat this up and get it all melty and see if we can get that thread engaging it. Oh geez. We've almost got it. Oh, I'm so close. Oh shoot, we're so close. Alright, as soon as we get this, I think I'm going to go through the comments and then we'll have to call this stream quits. But I think we've got pretty far. We got pretty much this whole x-axis going now, so pretty sweet. Well, actually, I think I gotta take off just in a minute here. But let's go over through the comments, see what's going on. No Nipex heresy. I agree. I think there was a heat set insert of this one, which I probably should have done. I would have enjoyed that installation process a lot more. But we made do with what we have. So there you go. And of course you need two because they're They come in a pair. Take the hot end out and do it properly. Ah, John, you know, that makes a lot of sense. That would have saved me a lot of time there. I don't know why you didn't tell me to do that earlier. But we're not about following instructions here. But yeah, I think we're gonna have to call it quits here. I've got pretty much the whole mechanical build finished. All that's left to do now is to just wire it up and put this electronics box together and close it up and turn it on. And you know, that's just how these projects go. They take way longer than you think they will. Anyways, thanks for tuning into the stream. I think we're one episode away from getting this thing printing. So I'll see you in the next episode, and hopefully we'll be able to get this thing laying down some plastic. All right, so see you in the next episode, and bye.